right, it is review time. So this question here is asking about the slopes and the y-intercepts. So let's just recall where those things exist. Oops. So that is our y-intercept and that is our slope of equations that have no solution. So here would be an example of a system of equations that has no solution. So this equation would be y is equal to plus 3 at the end, right? That's our starting point, and then 2x. Whereas this equation here would be y is equal to, again, the same slope. And then this is 1, 2, 3, 4, 5, 6, 7, 8.
Just a reminder, please don't forget to post your attendance for today. Once again, post your attendance. Thank you.
Oh, that's fine. Clearly, I'm still at school. All right, so for this one here, notice that these two lines here are never going to cross. So they are parallel to each other, and they therefore have the same slope. So what do you know about the slopes? They have the same slope because they are parallel. Whereas their y-intercepts here are different. They may be above or below, but they would be different. If they had the same y-intercept and the same slope, then they would be exactly the same line. And that would be an instance where they have the infinite number of solutions. So these guys coincide, this line and this line are the same. So if they have same of everything, then they have an infinite number of solutions because it's just a fancy way of saying it's the same darn thing. Whereas if they have the same slope but different y-intercepts, that means one is above and or below. So they have different y-intercepts. All right, hopefully that picture is helpful to you. So let's look at the rest of these. We're trying to figure out the systems that have no solutions. My suggestion is to just go ahead and put them all into y equals format because then you can compare their slopes and their y-intercepts. So first of all, every single one of these have the same slope. And let's go ahead and change this. So let's keep the y there for a moment and move the other one. So we have 3y equals negative 6x plus 12. And then let's divide by 3. So y is equal to negative 2x plus 4. I need to be careful about my sign here, then also careful that I divided everything by 3. So these are the two that we're talking about. That would mean that they are parallel to each other because they have the same slope, but they're going through different one. This one is higher and this one is lower. So this one here would have no solution, so we're going to circle that one. For this here, do you notice this is exactly the same? So I don't have to do all the work again. I know it's equal to y is equal to negative 2x plus 4. So again, same slope, but different y-intercept. This is way up there. This would be up here at 4, and then this one's way down here at negative 2. That one would also work. Notice nothing's different, so I don't need to do all the work again. We're just having you guys kind of look and see what's happening. Now look at this. Same slope and same y-intercept. Dude, this is the same line. So this is one right on top of the other. They're coinciding, so this would have an infinite number of solutions. And the last one here is y equals negative 2x plus 4. And so now, again, same slope, but totally different y-intercepts. So again, they would be parallel, meaning they have absolutely no solutions. So consider the system you did not circle, this one here. Describe its solution, like we just said, in infinite, and show algebraically why it's true. So that means that it should be like 0 equals 0, or 10 equals 10, or something like that. I'm going to use substitution. Because it's already y equals, I'm going to plug that in there. I'm going to have 6x plus 3 times negative 2x plus 4 is equal to 12. And just check to make sure I didn't lose a negative or anything along the way. I need to make sure I distribute it properly. So those cancel, giving me 0. And then I end up getting 12 equals 12. I could subtract a 12 on both sides and get 0 equals 0. Either one. Since this is what I have, that means that they must have been equal to each other.